Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 1, Section 1, Chapter 2, Topic 1, Part 2. Navigating the Frontier of Nanoelectronics, Exploring the Promise and Challenges of Nanoscale Electronics, Part 2. Challenges and Future Prospects. Despite the tremendous potential of nanoelectronics, several challenges must be overcome to realize its full impact on technology and society. Some key challenges include: 1. Fabrication and manufacturing. Fabricating nanoelectronic devices with precise dimensions and atomic scale precision poses significant challenges in terms of materials synthesis, lithography, and patterning techniques. Developing scalable manufacturing processes that are cost-effective and reproducible remains a key challenge in nanoelectronics. 2. Quantum coherence and decoherence. Maintaining quantum coherence and mitigating decoherence effects caused by environmental noise, material defects, and interactions with the surroundings pose fundamental challenges in quantum nanoelectronics. Developing error correction techniques, fault-tolerant architectures, and robust quantum control methods are essential for realizing practical quantum computing and quantum communication technologies. 3. Integration and heterogeneity. Integrating nanoelectronic devices into existing electronic systems and platforms while ensuring compatibility, reliability, and scalability presents formidable challenges. Overcoming interface and interconnect limitations, optimizing power delivery and thermal management, and addressing heterogeneous integration issues are critical for realizing the full potential of nanoelectronics in real-world applications. 4. Ethical and societal implications. As nanoelectronics advances, ethical and societal considerations regarding privacy, security, equity, and environmental impact become increasingly important. Addressing these concerns requires interdisciplinary collaboration, stakeholder engagement, and proactive regulatory frameworks to ensure responsible development and deployment of nanoelectronic technologies. Conclusion. In conclusion, nanoelectronics represents a frontier of scientific exploration and technological innovation with far-reaching implications for the future of electronics, computing, and beyond. By harnessing the unique properties of materials and phenomena at the nanometer scale, nanoelectronics pioneers breakthroughs in performance, energy efficiency, and functionality that hold promise for addressing grand challenges in areas such as healthcare, energy, and environmental sustainability. While facing formidable challenges, the relentless pursuit of nanoelectronics continues to drive progress and inspire researchers, engineers, and innovators to explore new frontiers in science and technology.